So calving, what is it? So calving is the process of ice breaking away from the main glacier and falling into the ocean. Glaciers melt away as temperature goes above freezing, and that's usually how they lose their ice. They just melt away. But calving is another process that breaks mechanically ice away from the glacier. That's another way tidewater glaciers can lose some ice. And it's a very specific process, super complicated, honestly. There's a whole realm of studies about tidewater glaciers, but they are absolutely fascinating because when you have all that amount of ice that just breaks away, it mixes all that water column that's in front of it, all that ocean water that's just in front of the glacier. It mixes sediments from the seafloor into the water, and basically every front of tidewater glacier where the glacier is calving into the ocean is a nursery for life. You have a lot of fishes that are eating all those nice nutrients the fishes that are eating all those microorganisms that are feeding on the sediments that are constantly being mixed by the falling ice or just ice breaking away. And if you have a lot of fish, and then you have a lot of animals like mammals that come and feast on all that, you have a lot of seals usually in front of tidewater glaciers. So it's really an extremely important factor for the coastal life. There's a video here. I hope it will show. Yeah. So just a small video about calving ice. I'm just gonna put that at a... Wow, that one is pretty big actually. I think it's maybe Perito Moreno, which is in Patagonia. Yeah, so anyway, you can look at that video. It's the link is embedded in the lectures. So tidewater glaciers, super important for all the marine life, all the coastal marine life. That's why Alaska is so famous for its whales and seals and all that you can see during the cruise or ferry boats around the coast. One thing you can do with the tidewater glacier is when calves, you can surf on it. It's a very bad idea. A lot of people have been too close to tidewater glaciers, and I can't imagine the amount of dead people from ice falling on them, or just like a tsunami like that. Because tidewater glaciers don't necessarily tidewater glaciers don't necessarily calve all the time, but when it happens, it can happen very fast, very suddenly, without any warning, and it can be pretty big. So the next type of glaciers are ice fields. Ice fields are starting to be kind of more blurry in terms of shapes. We had tidewater glaciers, Piedmont glaciers, and valley glaciers, and the others are kind of specific, you know, which glacier is which. But when you have areas of high elevation and a lot of precipitation, mountains like that, for example, just next to Juneau, you have all that ice accumulating, and it creates an ice field. Ice fields can be pretty big, and they're basically interconnected masses of ice. And whenever you have a mountain that's pointing out of the ice like that, we call that a nunatak. Just a few words about that. The JERP, the Junior Icefield Research Program, that's a program that runs for high schoolers and undergrads, I believe, just next to Juneau. It's an amazing opportunity. If you're interested in glaciers, you should absolutely apply to that program, because you're going to be on the ice for a few weeks, and as you walk through the ice field, you'll have PhD students just like myself who will teach you stuff about ice and stuff related to their specialization. So it's an incredible research program. if I were you, I would just jump on that opportunity and apply if I meet the requirements. So yeah. The next type of glacier are ice shelves. So ice shelves are glacier ice that's floating on the ocean. It's not sea ice. Ice shelves are not made out of sea ice. We'll make that distinction a bit later as well, detail that a bit more. The ice shelves are glaciers that are basically born into the mountains, are flowing, and at some, just like tidewater glaciers, they meet the ocean. And you can see ice shelves as enormous tidewater glaciers, and that are kind of merging all at the same place and forming a slab of ice that's floating on the ocean. Uh, Ice shelves are made of fresh water, and sea ice is made of saline water. Ice shelves can be hundreds of meters thick, while sea ice is usually maximum maybe a few tens of meters. If you have sea ice that's large, that's thicker than 10 meters of ice, then that's pretty unusual. Antarctica has a lot of ice shelves. Greenland basically doesn't have any, and they can be enormous places. Like if you're familiar with the metric system, you can realize that those ice shelves are the size of entire states. So yeah, just a small distinction between sea ice, ice shelves, and icebergs. So as I said, sea ice, ice shelves or glacial ice, fresh water that's coming from the mountains and floating on the ocean. And that's here delimited by this orange line. When the ice shelf is breaking away, is making chunks that float away, those are icebergs, and that's those red arrows that you can see. That is still fresh water, is just going away into the ocean and it's gonna melt at some point. And then sea ice is just the surface of the ocean that freezes when it's cold enough. So it's saline water, it's saline ice, saline water, and usually just a few centimeters to a few meters thick. Yeah, I'll talk a bit more about iceberg calving. You can call, for example, a tidewater glacier that's calving away. If you have a chunk of ice, that's an iceberg. But icebergs can be enormous. For example, that picture here from Antarctica, you have this chunk of ice, so this icebergs that's separated from its original ice shelf. And those extremities are basically the distance between Fairbanks and Delta Junction. So tidewater glaciers calve and can make icebergs. Ice shelves calve and can also make icebergs. And all of that ends up in the ocean and melts away somewhere. The next glacier shape are called ice streams. So ice streams can only be found really in Greenland and Antarctica. They are the main way that Greenland and Antarctica are getting rid of their ice that they are building up in the interior of the continent. For example, here on this map, we can see how fast the ice flows. If it's red, if it's green, it means that it's pretty slow, but as it starts becoming blue and red, pink, it means the ice is going super, super fast. And as you can see, it looks almost like a network of rivers. So it's not it's not that the ice is moving at once, just giant slab down to the ocean. It has those corridors of very fast and very thick ice. When I mean very fast is that ice streams can range from 100 to 1,000 meters per year. So you can sometimes see them moving with your bare eyes. They can be pretty thick, up to a kilometer thick, and very, very, very long, 500 kilometers. That's, if I'm not mistaken, almost the distance between Fairbanks to Anchorage. So imagine you're driving on a giant glacier that's going pretty fast from Fairbanks to Anchorage. That's how big those glaciers are. And they basically act as like rivers. They drain the ice sheet in the interior from its ice and delivers all of that into the ocean. And we can notice that a lot of those ice streams actually form ice shelves whenever they reach the ocean. Ice caps So that one is a bit of a blurry one. Ice caps are not necessarily bigger than ice streams, but they can be, because we are starting to reach the realm of very large amount of ice. Ice caps are very big ice fields, basically. They can be found mainly in you can have some in Svalbard. You have ice caps as well in Iceland. Here's a picture of Vatnajökull, which is in Iceland. Pretty cool ice cap, because below the ice there are some volcanoes, and whenever they erupt, they melt a lot of ice, and it creates rivers that are sometimes for like a few hours bigger than the Amazon. In terms of how much water they transport. So there are dome-shaped glaciers that covers entire regions, entire mountainous regions, covering less than apparently 50,000 square kilometers. And they're kind of characterized by that radial flow, meaning that the ice more or less accumulates in the middle. It's flowing out in every direction. You can see here a lot of glaciers on the southern side. There are some glaciers here on the northern side, a bit less, but the idea is that the ice is being created in the middle and it flows outwards. Sometimes there's some confusion about that term, like Arctic ice cap. That's not how those are called. And actually, when you talk about Greenland or Antarctic, those are not ice caps. They are the step above. They are ice sheets. Ice sheets are continent size. They are extremely big, extremely thick, represent a lot of ice, can be, I don't know, a few kilometers thick. Like Greenland and Antarctic, it's very common to have 1-2 kilometers of ice. And those are found only in Greenland and Antarctica. It's because those places have all the right conditions to create ice, to accumulate it in a fashion that it really grows and grows and grows, and eventually will create an ice sheet. And within the ice sheet, you can have other glacier shapes like ice streams, as we saw, that create also ice shelves, valley glaciers and stuff like that. So ice sheets are the end game. They are the biggest type of ice sheets of glaciers that we have on this planet. More than 50,000 square kilometers. So here's another picture of Antarctica, for example. It's relatively young ice, it's a relatively young ice sheet, 45.5 million years. So I don't know my history of Alaska that well. What was going on in Alaska at that time? Probably the Denali Range was being created. And there were more ice sheets before, during the last ice age. For example, we had the Cordilleran ice sheet, the Laurentide ice sheet. We had an ice sheet over Scandinavia that was called the Fennoscandian ice sheet. And at that time, the Earth was much colder. So basically, we could create ice sheets outside of Antarctica and Greenland and have those gigantic things sitting just on entire continents. Funny thing is, you can notice that Fairbanks, if you have very good eyes, Fairbanks was not under the ice during the last ice age. It was tundra environment, but it was not covered by ice. The Cordilleran ice sheet was, if I remember well, basically sitting at Delta Junction or a bit more south of Delta Junction. That's how far the ice was getting. So Alaska, surprisingly, was not that covered by ice sheets during the last ice age. I don't know exactly why. I guess it has to do with weather patterns and how much moisture in the air there was, how much humidity, and how much ice was accumulating there.